Hello dear children, and welcome all of you to the class of mathematics. We started with lesson real numbers, that is chapter number 1 before Diwali vacation, and completed the chapter up till exercise 1.2 question number 4. Today we are going to continue with the same lesson and solve the remaining sums from the exercise. So here we will begin. This is exercise 1.2 question number 5, and the question is, check whether 6 raised to n can end with the digit 0 for any natural number n. So we need to find this out, whether 6 raised to n is equal to any number, say 1, 2, 3, 4, 5, 6, 7, 8 and so on. So this number, whether it ends with the digit 0. So let's find out. So we'll take an example of the number which ends with digit 0. And you all are aware that such numbers are 10, 100, 20, 50, any number which ends with 0. So if we consider the number as 10, the factors of 10 are 2 into 5. If I take an example of 100, factors are 2 into 2 into 5 into 5. Look both the examples carefully and you will observe that the numbers ending with 0 has both 2 and 5 as their prime factors. Alright, check both the examples carefully and you will observe that 2 and 5 are the prime factors which are present in the number which ends with 0. But now our number is 6 raised to n, and I can factorize 6 as 2 into 3 and hold to the power n, and n can be any natural number. So if you factorize 6 raised to n, we will observe that it doesn't have 5 as a prime factor, and therefore we can conclude that this number doesn't end with 0. So this is how you have to solve. So we can say that 6 raised to n cannot end with 0 for any natural number n, because for a number to end with 0, it should have 2 and 5 as a prime factors. Alright, so let's move to the next sum. This is question number 6 from exercise 1.2, and the question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So to solve this sum, we need to first recollect what is the meaning of composite numbers. We have learnt about prime numbers, co-prime numbers and composite numbers. The number which has more than 2 factors are called as composite numbers. So let's first consider the number which is given to us. So we will consider 7 into 11 into 13 plus 13. From this number we can take 13 common. So if you take 13 common, in the bracket we will have 7 into 11 plus 1. So let's simplify this. We get 13 into 7 into 11 is 77 plus 1. 77 plus 1 is 78. So 13 into 78. We can factorize 78. So 13 into 3 into 2. From this, clearly it is seen that the number has more than 2 factors. And when the number has more than 2 factors, we call that number as a composite number. So the first number is a composite number. Let's consider the second number which is given to us. So we'll consider 7 into 6 into 5 into 4 into 3 into 1 plus 5. We'll do the same thing. Here we can take 5 common. So we will take 5 common outside. So what we are left with? 7 into 6 into 4 into 3 into 2 into 1 plus 1. Let's simplify this and we get 5 in the bracket 1008 plus 1. And 1008 plus 1 is 1009. So 5 into 1009 into 1, and we can say that the number has more than 2 factors. So the second number is also a composite number. So the important thing which you need to keep in mind here is you should know the meaning of composite numbers. Let's move to the next sum. This is exercise 1.2 and question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So how to solve this sum which is based on the chapter real numbers? Let's move ahead. So what is given to us is time taken by Sonia to take one complete round to the sports field is 18 minutes. At the same time, we are given that time taken by Ravi to drive one round to the sports field is 12 minutes. Now the question is, after how many minutes will they meet again at the starting point? Now the time taken by both of them to meet again will be the LCM of the time taken by both of them, that is 18 and 12 minutes. So we need to find out LCM of 18 and 12. Let's do that. Now to find out the LCM of 18, we will factorize it. So 2 9s are 18, then 3 3s are 9, and then 3 1s are 3. So we get 18 is equal to 2 into 3 into 3. We can also write it like 2 into 3 raised to 2. Similarly, we'll find LCM of 12. 2 6s are 12, then 2 3s are 6, then 3 1s are 3. So 12 is equal to 2 into 2 into 3. We can write it as 2 square into 3 raised to 1. Now to find out 18 and 12, to find out the LCM of 18 and 12, LCM is the product of greatest power of each prime factors. If you see the number 18, the greatest power is 3 raised to 2. If you see the number 12, greatest power is 2 raised to 2, and therefore LCM is equal to 2 raised to 2 into 3 raised to 2. That is equal to 4 into 9, and 4 into 9 is 36. And so time taken by Ravi and Sonia to meet again is equal to LCM of 18 and 12, which is 36 minutes. So this is how you have to solve the sum. They may change the numbers, like 18 and 12 given here, they may change the number, and same type of sum they may give you for the exam. Now there is one more method to find LCM of 18 and 12. Just have a look at this. You can also find LCM of 18 and 12 in this manner. So straightway both the numbers you can take together and find LCM of the two numbers in this manner. So 2 into 2 into 3 into 3, which comes to 36, and that is your answer. Alright, let's move ahead. Now this is exercise 1.3, and from 1.3 this is question number 1, which is very important, and the question is, prove that root 5 is irrational number. Now to solve this, we will make use of the method which is called as the method of contradiction. Now in this method we will exactly consider opposite to what is given to us. We have been given that root 5 is an irrational number. That is what we have to prove. So we will assume exactly opposite to this. We will assume that root 5 is a rational number. Now you all are aware that rational numbers can be written in the form of numerator upon denominator. So I can say that root 5 can be written in the form a upon b. So we know when we are writing the number in the form a upon b, that means a and b are co-primes, and meaning of co-prime is they do not have common factor other than 1. Alright, and therefore we can write square root 5 is equal to a upon b. We can write it in this manner. Square root 5b is equal to a. We have cross multiplied this. Now taking square of both the sides, what do we get? When we square both the sides, we get square root 5b the whole square is equal to a square. That will give us 5b square is equal to a square. Alright, I can write it in this manner. A square upon 5 is equal to b square. I have shifted this 5 to the denominator of a square. So what does this what does this statement say? This statement says that 5 divides a square, and we have a theorem which says that if p is a prime number and if p divides a square, then p divides a also, where a is a positive number. So by using this theorem, this indicates that if 5 divides a square, that means 5 divides a as well, isn't it? And we will consider this as equation number 1. Now just see, we can say that a upon 5 is equal to c, where c is some integer. Alright, so we can write a as 5 into c. Now we have the relation 5b square is equal to a square. Now in place of a, let us substitute 5c. So we have 5b square is equal to 5c the whole square. So we get 5b square is equal to 25c square. We can cancel this 5 and 25. So 5 5s are 25. What do we get? We get b square is equal to 1 upon 5 into 25c square. By cancelling this 5 and 25, we get b square is equal to 5c square. Alright, so b square upon 5 is equal to c square. So what does this say? Again, the theorem says that if p is a prime number and if p divides a square, then p divides a as well, where a is a positive number. And in our case, what do we get? 5 divides b square, so 5 divides b also. Correct? So we will consider this as equation 2. So considering equation 2 which we got, we conclude that 5 divides both a and b, and therefore 5 is a factor of both a and b, and therefore we can say that a and b have a factor that is 5, and therefore a and b are not co-prime numbers, because co-prime numbers has only one factor. Hence our assumption is wrong. So by contradiction we can see that square root 5 is an irrational number. In the beginning we assumed that square root 5 is a rational number, and any rational number can be written in the form a upon b, where a and b are co-primes. And the meaning of co-prime is both the numbers will have only one common factor, that is 1. But when we solve the sum, we got to know that a and b have one more factor, that is 5. So it doesn't have only one factor, that is 1. It has 5 also as a factor. And therefore our assumption that square root 5 is a rational number is wrong. And this contradicts our statement. And so we can say that square root 5 is an irrational number. Such type of sums we will solve again, children. So few more sums are there in the exercise that we will continue in the next video lesson. Until then, this particular sum please revise once again, and see you all in the next video lesson. Bye and take care all of you.